14, f of x is 12.95. I can also use this table to find x when I give you the f of x, the y. So now I go to where f of x is 2.95 and x there is 6. So I could write that f of 6 is 2.95. Or I could write this as a point, 6, 2.95. Because again, f of x is the y. If I'm given here f of x equals 4x squared minus 3, if this were y equals, then I could graph and determine whether it's a function or not. Since it's f of x equals, then I don't have to look at it to determine whether it's a function. This is telling me, yes, this y equals, this equation is a function. Also, it defines that the variable I'm using in my equation is x. So that's why I have x here. If I had a different variable, n, or another letter, I could put f of n, and then that just means I have an n here. To find f of 2, here, this means that I'm defining x as 2. So I want to know the y. My question is, when I have 2 f of 2, what is that value? So the way I do a calculation is, see, here is x, here is 2. I'm defining x as 2. So everywhere that I see x, I'll take the x out, and I'll put a 2 instead. So I'll put a 2 here. I recommend to use parentheses anytime you substitute. For f of 2, I'll write the rest of the equation, and I'm going to take x out and make a space there to substitute. And because I'm trying to find f of 2, then I'll put a 2 here. If I wanted to know f of 0, I would put a 0 here. I'm saying x is 0. If I need an f of negative 16, I would put negative 16 here. I'm just defining which x I want to solve for. So then I do a calculation. Now I added these parentheses myself, but I have an exponent here. So for order of operations, you do exponents first, parentheses, and exponents. So 2 squared, I'll do first, which is 4, times 4 is 16. And then I subtract 3. You can also do this in your calculator. 4 times 4 is 16. I multiply before I subtract. 16 minus 3 is 13. So I found that f of 2 is 13. So I can put that here. If I were to find f of 3, I work this the same way, but I substitute negative 3. Go ahead and do that. Hit pause and then check yourself. The first thing I do is I take the x out because I'll write negative 3 where the x was. Also in the equation, I make a space where I can substitute, and I'll put negative 3 in place of x. When I finish my calculation, I find that f of negative 3 is 33. I can check this by graphing my original equation, 4x squared minus 3, and then checking my graph or my table. I can look where x is 2 and verify that y is 13. I could also check where x is negative 3 and verify that y is 33. I would do this the same way if g of x was equal to 3x minus 4 and I wanted to find g of x plus 2. This time I'm substituting not a number but a algebraic expression. Anytime I want to find g of something, I multiply 3 times something minus 4. That's what g does. If it was g of 2, I would put a 2 here and a 2 there in place of x. This time, in place of x, I'm finding g of x plus 2, so I put x plus 2 here instead of x. Next, I distribute, and I find 3x plus 3 times 2 is 6 minus 4 as my next expression, and then I can combine these constants, and g of x plus 2 is 3x plus 2. If I were asked what x is when g of x is 8, I still use the same equation for g of x, but this time I'm looking for x. This is my question, and I know what g of x is, so I've been given y. I substitute here. So if g of x is 8, then I write 8 equals 3x minus 4. And I solve for x. So I add 4. And I divide by 3, and I find that x is equal to 4 when g of x is 8. And you can graph and check.